Hello dear students, welcome back to our channel. I am your maths teacher CG ma'am. In this video we are going to start the first exercise of this lesson, that is exercise 8.1. In the first question we have given a right triangle ABC right angled at B implies angle B equal to 90 degree and the side AB is 24 centimeter and BC equal to 7 centimeter. Okay, and there are two sub questions. Okay, we have to find out sin A, cos A, and in the second sub question sin C and cos C. Very simple question. Okay, that means we have to take these two acute angles for the reference, and with respect to angle A you will get sin A, and with respect to angle C you will get sin C. In the same way, with respect to angle A you can easily calculate cos A, and with respect to angle C you will get cos C also. Is it okay, children? Okay. See, here in this right triangle we have given only the two sides, and sin A by the ratio we know that what is sin A, children? Sin A is nothing but opposite side by hypotenuse. Okay, in order to remember this ratio without mistake, you can think of this one, that is O, A and O. And here it comes in the first ratio, sine opposite side by hypotenuse, adjacent side by hypotenuse, opposite side by adjacent. O, A, O, H, H, A. Okay, and these are the ratio for the first three basic trigonometric ratio. Okay, otherwise I already told, first you have to mark the opposite side, secondly adjacent side, and there is no change for the hypotenuse of a right triangle. Okay, anyhow you should by heart it without any mistake. Okay, so this is all about the ratios. Okay, so we have to find out that hypotenuse, that is opposite side and adjacent side are given. With respect to angle A, this is the opposite side and this is the adjacent side. Okay, how the third side can be found? By using Pythagoras theorem. Okay, so by Pythagoras theorem, okay, then only we can substitute for hypotenuse. Okay, so AC should be found first. So, by Pythagoras theorem, AC square is equal to AB square plus sum of the squares of other two sides, BC square. Okay, that is AB square is 24 square plus 7 square. That is, what is the square of 24, children? It would be better to learn squares from 1 to 30 and cubes from 1 to 10. Okay, that will help you to get the solutions quickly. Okay, so 576 plus 49, and by adding 9 plus 6 for 15, 1 carries, 7 and 4 11 plus 1 12, 1 carry, and 6 5 plus 1 6, 625. This is AC square, square of the hypotenuse. Okay, but in sin A, opposite side by hypotenuse, so that means we have to find out AC. AC is the AC square. AC square from how can we write AC from AC square? Take the square root on both sides. Okay, so square root of 625, you will get positive and negative 25, but since it is side you can consider only the positive value, that is 25 centimeter. Okay, and after getting hypotenuse, the remaining thing is very simple. Okay, then what will be sin A? Sin A is nothing but opposite side by hypotenuse. Opposite side is already given, that is BC. So, this is equal to BC by hypotenuse AC. So, sin A is equal to BC 7 divided by 25. We have seen that hypotenuse is equal to 25 centimeter. Understood? Okay, this is all about the first one, 25 centimeter. Okay, the same way how this is cos A. Cos A, what is by definition? What is cos A ratio? Cos A is equal to, reference angle is A, that is equal to adjacent side divided by hypotenuse. adjacent side by hypotenuse. Okay, hypotenuse, and adjacent side in this case with respect to angle A 24, and hypotenuse is same for any ratio, because that is the longest side, that is we have seen that is 25. Okay, this is the cos measurement of, that is ratio of cos A is equal to 24, that is adjacent side by this opposite hypotenuse. This is the opposite side and this is the adjacent side with reference to angle A. This is all about the first sub question. And in the second sub question, we have to find out sin C. See the reference angle. So we have to take the reference angle, that is acute angle, as C, and with respect to angle C, okay, with respect to angle C, okay, this AB is the adjacent side, AB is the opposite side, and the adjacent side is BC. BC is the adjacent side with respect to angle C. Okay, then by definition, by what is sin C? Sin C is equal to sin C, whether it is angle A or angle C, sin, the ratio is opposite side by hypotenuse. Okay, so sin A, sin already we have seen, sin C. This is first sub question. Okay, and this is the second one. Okay, sin C is equal to, with respect to angle C, opposite side is AB divided by AC. Okay, AB is 24 divided by 25. And cos C, okay, cos C, that is with respect to this angle C, adjacent side is BC, BC by AC. It would be better this side, okay, before writing the measurement of the side, okay, to avoid mistake. Okay, so BC is 7 centimeter divided by AC is 25 centimeter. This is cos C. Understood? This is all about the first question. In the second question, we have given a right triangle PQR, right angled at Q. That means angle Q equal to 90 degree. Okay, also PQ, the measurement of the side PQ is 12 centimeter, and that hypotenuse, the side opposite to 90 degree is the hypotenuse, and that is also given, that is 13 centimeter. Okay, and what is asked? We have to find out tan P minus cot R. If angle Q is 90 degree, implies angle P and angle R are acute angles. So you can define trigonometric ratio upon these two acute angles. Okay, so tan P. So first we can take the reference angle as P. Okay, with respect to angle P, okay, its opposite side is QR. So this is opposite side. Okay, and this is adjacent side. Okay, and definitely this is the hypotenuse. Okay, and we know what is that opposite and adjacent, opposite here H, H, A. Okay, this is sine, cos and tan. Okay, and with respect to angle P, tan P, what is tan P? Opposite side by adjacent side, that is tan is free from hypotenuse. Okay, but sine and cos denominator is hypotenuse. Okay, so tan P, this P indicates the reference angle with respect to which acute angle? Here we are taking the first reference angle as P. So tan P, so that angle we have to write along with the ratio. We are usually using the capital letters of the English alphabet or Greek letters, theta, phi, alpha, likewise. Okay, so tan P is equal to opposite side by adjacent side. Adjacent. Okay, okay, so but here opposite side is not given. Okay, so in any one of the side of a right triangle is not given, you can easily find out by using very important theorem, that is Pythagoras theorem. Okay, so if hypotenuse is asked, that the square of the hypotenuse is equal to sum of the squares of other two sides. Any one of the side is needed, You have to subtract the given side from the square of the hypotenuse. Okay, that means QR square is equal to what is that? Square of the hypotenuse PR square minus PQ square. Understood? Or you can write the first step, PR square is equal to PQ square plus QR square. Then from that you can write this QR square is equal to by taking this PQ to RHS or minus. That is how we got this equation. Okay. Then we can directly get its opposite side. Okay. So PR is given as 13. That 13 square minus PQ 12 square. 13 square 169 minus 144. Okay, 169 minus 144, 5 to 25. That is, this is square of QR square, that is opposite side. And we need opposite side, okay, that is by taking the square root, you will get square root of 25. We are taking the positive value, that is 5 centimeter. If you know the opposite side, you can easily write down tan P with respect to angle P. Tan P is equal to QR divided by adjacent side is given, that is PQ. Okay, so tan P is equal to QR. Now we have seen that 5 centimeter. 5 divided by PQ. 12. Okay, so this is what is tan P. Okay, usually the ratio has no unit, so trigonometric ratio also has no unit. It may be any real number. Okay, so no need to write down 5 by 12 centimeter. That is, the unit get cancelled. No unit for the ratios. Okay, trigonometric ratios. So 5 divided by 12. Is it clear, children? Okay, and here we have to find out quarter, then only we can subtract. Okay, so with respect to angle R, okay, this is the opposite side and this is the adjacent side. Okay, so by definition, what is cot? Okay, cot R is equal to take the reciprocal of tan, adjacent side divided by opposite side, adjacent divided by opposite. Okay, from the figure, what is adjacent side? With respect to this angular adjacent side is QR, that is QR divided by its opposite side. Okay, if you, in order to avoid mistake, you can rub the first case. Okay, that is with respect to angular adjacent side QR and opposite side is PQ. Okay, so QR we already have seen 5 divided by 12. Okay, and what is asked, children? Tan P minus cot R. Okay, tan P. Okay, therefore tan P minus cot R. See, QR minus PQ, here also QR minus PQ, there itself you can write 0 minus. Okay, but sometimes if it comes for 2 marks, okay, you have to find out the other sides, and in this way would be the better. Okay, that is why we have seen by applying the Pythagoras theorem, that is the side QR, then we can get these two ratios and finally you can subtract. Okay, so this is equal to tan P, that is 5 by 12 minus 5 by 12, cot R is equal to 5 by 12. Okay, 5 by 12 and that is equal to 0. That means tan P minus cot R is equal to 0. Quite simple problem. Okay. Now we are solving the third question of this exercise. Here in this question, if sin A is equal to 3 by 4, sin A is equal to 3 by 4, calculate cos A and tan A. Figure is not given. Meantime, children, it's very important remark I am going to explain now. That is, since sin A, what is sin A? Sin A is opposite side by hypotenuse, right? That means hypotenuse is the longest side, that we know. Okay, that means, and in the numerator at any cost, that means the opposite side definitely always less than the hypotenuse. Understood? That means sin A is always a proper fraction. Understood? The same way cos A also. Cos A means adjacent side by hypotenuse. In both cases, the denominator is hypotenuse, so it will be the longest side. So the numerator is always less than the denominator. So sin A and cos A will be always a proper fraction. Understood? Okay. So we have to draw the figure first. Sin A. So by definition, what is sin A, children? Sin A is equal to opposite side by hypotenuse. Okay, so here the reference angle is angle A. That means we can draw a right triangle ABC, right angled at B, because here A is acute angle. Okay, so either B or C, that doesn't matter. Okay, so I am drawing a right triangle ABC, right angled at B. Okay, so this is sin A is 3 by 4, that means opposite side divided by hypotenuse is equal to 3 by 4, right? Okay, and since we know that the fraction should always express in its least form. Okay, if this side is equal to 6 by 8, it can be, okay, by reducing you will get 3 by 4. Okay, that means 3 into 2 into 2. That is after cancelling these common factors, the least form is 3 by 4. That means here the opposite side you can definitely write without any doubt. That is the 3, the side opposite to the reference angle, that is this is 3, and that is hypotenuse. That is hypotenuse is equal to 4. With respect to angle B, the longest side is hypotenuse. Okay, so what is asked, children? We have to calculate cos A. Cos A means adjacent side divided by hypotenuse. So adjacent side is not given. So in order to get cos A, we have to first find out AB, okay, by using Pythagoras theorem. If the right triangle is given, any one side is unknown, you can definitely apply in any problem Pythagoras theorem. Isn't it? So we are going to find out adjacent side. So here the reference angle is angle A. So opposite side, this is the adjacent side. Okay. So by definition, that is applying the Pythagoras theorem. Again, I already told in the previous case, if side is needed, you have to subtract the known side from the square of the hypotenuse. Okay. That means AB square by Pythagoras theorem. AB square is equal to, what is that? Square of the hypotenuse minus this BC is given. BC square. Okay. So AC square 4 centimeter. 4 square minus 3 square. Okay. 3 square, that is 16 minus 9. Okay. What is 16 minus 9? That is equal to 16 minus 9 is 7. Okay, so this is AB square. In order to get AB, you have to take the square root. So root of 7 centimeter. Okay, so here we have seen that AB as root 7 centimeter. Okay, root 7 centimeter. Okay, this also in centimeter. Individually you can write the unit, but if you take the ratio, the unit get cancelled, so no unit for trigonometric ratios. Okay, so this is what is the way how can we find out the adjacent side, that is root 7. Then finally now we have all the 3 sides, so whatever the ratio is required you can easily write down. Okay, so first we need cos A. Cos A is equal, by definition, adjacent, second ratio, so adjacent side. Okay, that is adjacent divided by hypotenuse. This is hypotenuse. Okay, hypotenuse. Okay, so adjacent side we already have seen that root 7 divided by 4. Okay, and tan A. What is tan A? Reference angle is angle A. The second case also. So tan A is equal to opposite side by adjacent side. Okay, opposite divided by adjacent side. Okay, so opposite side is with respect to angle A, opposite side is BC divided by AB. So 3 divided by root 7. Okay, this is all about the third question. Okay. In the fourth question, we have given 15 cot A is equal to 8. This is one of the important problem of this exercise. 15 cot A is equal to 8. We have to find out sin A and sec. Okay, so we can first draw a right triangle. Okay, because trigonometric ratio is defined for right triangle. Okay, so right triangle A must be the reference angle. Okay, so right triangle ABC, right angled at B. Because sin A, sec and also given, that is very important, 15 cot A is equal to 8. So reference angle must be angle A. All the three carries A as the reference angle. Yes, children? So children, see in the previous cases, all the problems, we have given that a ratio, only ratio in the LHS. Sin A is equal to 3 by 4. Likewise. But here in this question, 15 cot A. So from that you have to write what is cot A. Okay, since it is given that 15 cot A is equal to 8 implies what is simply cot A. You have to take this 15 to RHS. Okay, in the RHS already 8 is there. So 8 and 15 comes in the denominator. 15 in the denominator. So 8 by 15 is cot A. And by definition, okay, what is the ratio of cot A? That is adjacent side by opposite side. Okay, adjacent divided by opposite. Okay, this you can remember always, children. Opposite side by hypotenuse, adjacent side by hypotenuse, opposite side by adjacent side. Okay, sine, cos and tan. Okay, so adjacent side by opposite, that is cot A, that is 8 is the adjacent side with respect to angle A. With respect to angle A, the adjacent side, okay, adjacent side is AB and that is 8. Whatever the ratio, whatever the common factor, after reducing that you will get the ratio, that is in the simplest form, that is 8 is the adjacent side and 15 is the opposite side, 15 centimeter. Okay, and what is a sin A? Sin A by definition, what is sin A? Opposite side by hypotenuse. But hypotenuse can be easily find out by using Pythagoras theorem. Okay, so by Pythagoras and also for sec. Sec is the reciprocal of cos A. Okay, cos A means adjacent side by hypotenuse. So it is the reciprocal is hypotenuse divided by adjacent side. So in the both cases you have to find out hypotenuse. Okay, so this with respect to angle B, this is the hypotenuse. So in order to get the hypotenuse, that means applying the square of the hypotenuse. So if hypotenuse needed, you can add the square of the other two sides. If any other side is wanted, you have to subtract the third side from the square of the hypotenuse. Understood? So AC square is equal to, by Pythagoras theorem, okay, square of the hypotenuse AC square is equal to AB square plus BC square. Okay, AB square is 8 square, okay, plus BC is equal to 15 square, that is 64 plus 225. Okay, 225 plus 64. Okay, 225, 60 to 89. Okay, 6 plus 2, 8 and 2 to 89. And in order to get AC from the square root, From this you have to take square root of 289, and that is nothing but 17, plus or minus 17, but we are taking only the positive value, and we have seen that 17 centimeter is a hypotenuse. Understood, children? All these problems are quite simple, can be expected for a 1 mark question. Okay. So sin A, by definition, what is sin A? Sin A is nothing but opposite side by hypotenuse. Okay, and opposite with respect to angle, opposite side is 15 divided by 17. See, I already mentioned about the value of sin is always a proper fraction. That is, numerator is always less than the denominator. Okay, hypotenuse comes in the denominator. That is the reason. And CK. CK is the reciprocal of cos. Okay, these are the 3 basic trigonometric ratios, and the other 3 is the reciprocal of these 3. The first is sin, cos, tan. Sin the reciprocal cosec, and sec is the reciprocal of cos, and cot is the reciprocal of tan. Okay, so sec A is the reciprocal of cos, so hypotenuse divided by adjacent side. Hypotenuse divided by adjacent side. Okay, what is hypotenuse with respect? Anyhow, this is a right triangle, so opposite side of the angle AB, that is hypotenuse, 17 divided by adjacent side. Adjacent side is 8. Okay, if sin A and cos A is proper fraction, in the same way you can say it's a reciprocal. Cosec and sec, the reciprocal of sin, cosec and sec, since the numerator is hypotenuse, that is greater than, always greater than the opposite side, and in case of cos, adjacent side. Okay, so it will be an improper fraction. So that means numerator is always greater than the denominator in case of cosec and sec. Okay, so this is all about the 4th question. Now we are solving the 5th question. In this question, we have given sec theta is equal to 13 divided by 12, and we have to find out all the remaining trigonometric ratios. We know that we have altogether 6 trigonometric ratios. That means we have to find out the remaining 5 trigonometric ratios. And also we have to draw first a right triangle, because we can define the ratios only for the right triangle. Okay. So what is given, children? Sec theta. What is sec theta? Sec theta is that reciprocal of cos, right? So cos theta, and for remember that one, we know that relation, that is OAO and HHA. Okay, so this is sine, and this is cos, and this is tan. Opposite side by hypotenuse, adjacent side by hypotenuse for cos, and opposite side by adjacent for tan. These 3 are the basic trigonometric ratios, and the remaining 3 are the reciprocal of these, taken in the order, that is cosec and sec, cot. These are the reciprocals of these 3 basic trigonometric ratios. Understood? Okay, and since here we have given sec theta, that is the reciprocal of cos. Understood? Okay, so I am drawing first a right triangle, and we can give the theta for one of the acute angle. That is the meaning of sec theta. Okay, and the previous problems we have given sec, tan P, likewise. That means there that angle P is acute angle, angle A is the acute angle. But here instead of the vertex, okay, it is that theta represents here the measure of the acute angle. Understood, children? So we can draw a right triangle. Okay, and you can name any letters. Okay, a triangle ABC or triangle PQ, doesn't matter. But the only thing is, theta must be given to any one of these 2 acute angles. Okay, so I am giving for angle C as theta. Understood? Okay, since it is given in terms of sec theta. Okay, and see, children, here what is sec theta? Sec theta is a reciprocal of cos, that means hypotenuse divided by adjacent side. Okay, so hypotenuse divided by adjacent side. Okay, hypotenuse divided by adjacent side. and that can be marked as 13 by 12, that is given. Which implies with respect to angle theta, we can first mark the side. Okay, that means here the opposite side is AB, AB, and this is adjacent side, and this is always the side opposite to 90 degree is always hypotenuse. Okay, hypotenuse. Okay, so here the adjacent side, here that sec theta hypotenuse by adjacent. So hypotenuse is 13. Okay, 13 numerator, and the adjacent side is 12 centimeter. Okay, and we have to find out, definitely we have to find out the opposite side, then only we can write sin theta, cosec theta, and tan theta also opposite side by hypotenuse, and its reciprocal cot also hypotenuse divided by opposite. So we have to find out opposite side first. And since that is one of the side of the right triangle, okay, so we can apply the Pythagoras theorem to get the opposite side. Okay, so in order to get the square of the hypotenuse, you have to add the squares of sum of these two sides. If you need side, you have to subtract this side from the square of the hypotenuse. Okay, so we can apply the Pythagoras theorem. By applying Pythagoras theorem, AB square is equal to AC square from square of the hypotenuse. You can subtract the square of the this side. Okay, and AC is given as 13 square, BC is 12 square, and 169 is the square of 13, 144 is the square of 12. And by subtracting, you will be getting 25. This is AB square, square of the opposite side. But we need simply AB. So AB, by taking the square root, okay, 25 plus or minus, but here only 5 if because it is length of the side. It never be, what is it, a negative. Okay, so 5 centimeters. So 5 centimeter. Okay, so now we have all the three sides. The next is simply apply that idea in order to get the 5 trigonometric ratios. Okay, children. So after getting sec theta, what will be its reciprocal? Reciprocal is cos. Okay, that means cos theta is equal to, okay, so 5 is the opposite side. So we can write the remaining 5 trigonometric ratios. Cos theta is equal to, what is cos theta? Adjacent side, its reciprocal divided by hypotenuse. So 12 by 13. Okay, and sin theta. Sin theta is, so children, you have to write here theta. Okay, don't write C, because we have taken the measure of angle C as theta. So you have to write here theta. Okay. So sin theta is equal to opposite, and opposite divided by hypotenuse. Okay, opposite is 5 divided by 13. Okay, cos already we have written. Now comes tan. Okay, tan theta is equal to, and in the same step you can write cosec. Cosec theta is equal to the reciprocal. Okay, that is hypotenuse divided by opposite. Okay, hypotenuse divided by opposite, the reciprocal of sine. So that means 13 divided by 5, sine and cosec, reciprocal. Then the third basic trigonometric ratio is tan, that is opposite side divided by adjacent side, adjacent side. Okay, so what is opposite side? 5 we have seen, and the adjacent side is 12. Okay, so cot theta I am writing here. Cot theta reciprocal of tan will be, that is adjacent by opposite, that is 12 divided by 5. This is the way to find out the remaining trigonometric ratios. Just to draw a right triangle and get the third side by applying the Pythagoras theorem and write down the correct ratios. Okay? Yes, children, now we are moving to the sixth question. Now we are solving the sixth question. In the sixth question, what is given, children? Angle A and angle B are two acute angles such that cos A equal to cos B. We have to show that angle A is equal to angle B. Understood? This problem can be done in different ways, but I am giving you very easiest method. Okay, that means what is given, children? Angle A and angle B are two acute angles. That means in a right triangle, let angle A and angle B are the acute angles. So I am drawing a right triangle ABC, right triangle ABC. Okay, and I am marking angle A and angle B as acute, and definitely this will be angle C. Okay, and since cos A equal to, it is given that cos A equal to cos B. We can write what is cos A and cos B with respect to angle A. Okay, what is cos A with respect to angle A? This is angle A. Cos A is nothing but, see children, OAO HHA. Understood? So cos A, that is adjacent by hypotenuse. So this is adjacent with respect to angle A. This is adjacent. Okay, and definitely side opposite to 90 degrees, hypotenuse always, no change for whether it is angle A or angle B. Okay. So we can write what is cos A. Cos A is equal to ACD, which implies cos A adjacent by hypotenuse, that is AC divided by AB. This can be equated to cos B. Okay, with respect to angle B, cos B means adjacent. Okay, adjacent here with respect to angle B, this adjacent side is BC. Okay, that means this is with respect to angle B, this is adjacent. Okay, and hypotenuse, no change for whether A or B, that doesn't matter. So we can write what is it? ABC divided by AB. See children, with respect to angle A, cos A equal to AC by AB, here BC by AB. See, in both sides, LHS and RHS, the denominators are same. See the denominators, that is both having hypotenuse, and no change for that, because in a right triangle only one hypotenuse. Okay, that means, which implies if both sides, okay, having the denominators are same, we can equate the numerators, which implies AC equal to BC. Understood? This, since AB and AB on both sides are equal, implies we can equate the numerators on both sides, that is AC equal to BC. Now see, what is AC and BC in the figure? AC is this side, and BC, they are equal, and we know that angle opposite to equal sides are equal. Which is the angle opposite to the side AC? Angle B. Okay, which is the angle opposite to side BC? Angle A. That is angle A is equal to angle B. That is this is what we need to prove. Angle A is equal to angle B. What is the reason? Angles opposite to equal sides are equal. Okay, this reason you should write in bracket, then only you will get the full mark. Okay, so this is very important problem, but it's quite simple, but you should know the correct idea and write down what is with respect to angle A cos A, and with respect to angle B cos B, and you can equate the numerators, and finally you will get the required answer. Okay, this is all about the sixth problem. Now we are moving to the seventh question. Now the seventh question, here it is given that cot theta is equal to 7 by 8, and we have to evaluate first one 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus sin theta, and the second sub question, what is cot square theta. Understood? So children, we can look into the first part, that is 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. Children, see, this can we write this 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta can be written in the form. Children, here one point to be noted very carefully, that means you can apply the algebraic identities for these trigonometric ratios. That means this is of the form a plus b into a minus b. Isn't it? A plus b, this is a plus b into a minus b. What is a plus b into a minus b? Identity, that is a square minus b square. By using that identity, the numerator can be written in the form a square. 1 square is 1 itself minus sin theta into sin theta. Okay, children, we are not squaring. See, if we have sin theta into sin theta is, we are simply writing sin square theta. We are not squaring theta. Okay, that means we are taking the reference angle as theta and the ratio we are squaring. We are not squaring the angle. Okay, sin theta into sin theta is sin square theta. In the same way, see children, this can be written as sin theta whole square. Okay, but this is equal to sin square theta. We are not squaring for theta. This should be very carefully noted. Okay, so here a square is 1 square is 1 itself, and b square, a square minus b square, the identity, that is sin theta into sin theta is sin square theta. Sin square theta divided by, see, the same identity can be used for the denominator. Yes, this is also in the form a plus b into a minus b. So, a square minus b square. A here also 1. So, 1 square is 1 itself minus cos square theta. What is cot theta? Cot theta, in order to get easily, we know that relation OAO HHA. So, third ratio, its reciprocal is cot. That means this adjacent side divided by opposite side, and that is given as 7 by 8. Okay, that means in a right triangle, you can draw a right triangle and we have to find out the opposite side and hypotenuse, opposite side and adjacent and given. So, we have to find out the third side, that is the hypotenuse. Okay, that means we can draw a right triangle and we can find out the third side. Okay, that means from this relation cot theta, we can easily find out the hypotenuse. Okay, so here right triangle ABC, right angle at B, and cot theta, theta can be given for any of the acute angle, either A or either C you can give. Okay, so I am giving for angle A as theta. With respect to theta, okay, is cot theta, adjacent side is 7 and opposite side is 8. Okay, so by applying Pythagoras theorem, we can find out AC square first. Okay, so by Pythagoras theorem, AC square is equal to hypotenuse we need, so sum of the other two sides. Okay, take the square of the sum of other two sides. That means AB square plus BC square, that is 7 square plus 8 square. Here comes 49 plus 64. Okay, 9 plus 4, 13, 1 carry, 6 plus 4, 10 plus 1, 11. That is AC square, square of the hypotenuse is 113, and AC we need the hypotenuse, that is square of 113. Okay, that is this side, the hypotenuse we have seen that 100 and root of 113. That means now we have all the three sides. Okay, then so that you can easily write down the sin theta and take its square, you will get sin square theta, and cos theta also you can easily get it from these three sides. Understood? That is what we are going to do here. Okay, so after getting this hypotenuse, we can write sin theta is equal to sin theta, that is opposite side by hypotenuse. What is opposite side here? With respect to angle theta, opposite side by hypotenuse, that is 8 divided by root 113. Okay, Cos theta also we need cos theta for getting this to evaluate this, that is cos theta is equal to, with respect to angle theta, adjacent side by hypotenuse, that is 7 divided by root 113. Understood, children? So now we are moving to substitution part, that is this should be substituted over here. We have reduced this into that form by using the identity a plus b into a minus b. Is it okay, children? So this becomes 1 minus, if sin theta is equal to 8 by root 113, sin square, you have to take the ratio as square, that is 8 by root of 113 whole square. Understood? Sin square theta is nothing but sin theta whole square. Sin theta is 8 by root 113. Take its square, that will be sin square theta. Divided by 1 minus cos square theta. The same rule we are applying. So cos square is 7 by root 113 square. Hope this step is clear, children. Okay, we just square have taken the square of sin theta and cos theta in order to get sin square theta and cos square theta. Okay, so children, and this becomes 1 minus, okay, what is a by b whole square? A by b whole square is a square by b square. So take the square of numerator and denominator separately. Okay, that is 8 square. 8 square is 64 divided by 113. If you take the square of square root, root x whole square is x itself. The square root and square get cancelled. Okay, so if you in order to remove the square root, you just square them. Okay, so that becomes the square of 113 is simply 113 divided by, okay, 1 minus, same we are applying here also, that is 7 square 49 divided by 113. Hope the idea is clear, okay? Yes. Now we can solve that step in order to get the final answer. Okay. So children, 1 minus 64 divided by 113. That means the second term is a fraction. 64 divided by 113. So since they are connected by plus, if it is connected plus or minus, you take the cross multiplication or LCM method. So we can cross multiply. So 1 into 113. Okay, that is 113, okay, minus 64, here 1, okay, so 1 into 64 divided by 1 into 113, 113 divided by the numerator, the same rule we are applying, okay, since 1 and 49 by 13, the two terms are connected by minus sign, you have to cross multiply, okay, that is 101 into 113, 113, okay, you can suppose here is 1, so 1 into 49 minus 49 divided by 1 into 113, 113. Okay, yes. So what can be the next step I am writing over here? Okay, so 113 minus 164 divided by 113. So you can subtract, or in this step itself you can reduce. Okay, and I already told if two fractions are coming for division, take the reciprocal of the second fraction, then multiply. Okay, that can be done after subtracting, getting difference between 113 and 64. Then we have seen that that will be 49. 49 plus 64 gives 113. So subtraction you will give 49 divided by 113. And 113 minus 49 will be 64 divided by 130. Okay, those who have correct idea, in this step itself you can cancel 113. Okay, or you can write one more step, that is take the reciprocal of the new denominator, no change for the numerator, and we can multiply with the reciprocal of the second. Okay, reciprocal of the second is 113 divided by 64. So this can be cancelled and finally you will be getting 49 divided by 64. Okay, this is the value you will get after evaluating this first part, that is 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. Simply we applied that identity a plus b into a minus b is equal to a square minus b square. And another important thing is sin square theta or cos square theta is nothing but the square of sin theta. Okay. Now the second part. What is the second part? It's quite simple. Cot square theta. Okay, what is cot square theta? Cot theta whole square, right? And cot theta is given, children. Cot theta is given as 7 by 8. Okay, 7. If that is 7 by 8, yes. So cot square theta equal to, can we write cot theta whole square? And cot theta is given as 7 by 8 whole square, that is 49 by 64. Square of 8 is 64, 7 is 49. Okay, a by b whole square is a square by b square. Okay, so the both case we have got the same answer, 49 by 64 after evaluating the first question, and the cot square also very simply you can write down. Okay, that is 49 divided by 64. Okay, now we are moving to the next problem. In the 8th question, we have given 3 cot A is equal to 4, and we have to check whether 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A or not. Okay, this is very important question, can be expected. Okay, so what is given? We can start from what is given and we can reach very easily into the answer. Okay, that means 3 cot A is equal to 4. Okay, so given 3 cot A is equal to 4. Children, very important point is we have to keep the ratio alone in LHS. Here in LHS 3 times cot A, that means in order to keep the ratio, that is cot A alone, that means you have to take this 3 to RHS, so under division, so 4 by 3. Okay, so what is cot A? The reciprocal of tan A, that is adjacent side divided by opposite side. Okay, adjacent side, okay, divided by opposite side. Okay, here 1 minus tan square A divided by 1 plus tan square A. In order to get that one, so tan is a reciprocal of cot. So we don't want that hypotenuse in the LHS part. But in order to solve whether that is equal to the RHS, there is cos square minus sin square, and cos square is adjacent side by hypotenuse. So in order to solve the RHS part, we need hypotenuse. But here only adjacent side and opposite are given. So that means we have to find out the third side, that is hypotenuse. By drawing right triangle, by applying Pythagoras theorem, find out the third side. Okay, so that is the first step, that is I am going to draw a right triangle ABC, okay, and A must be the acute angle, okay. So right triangle ABC with respect to angle A, since cot A. Okay, so the angle near to the cot, the ratio must be acute. Okay, so cot A is adjacent 4 and opposite 3. Okay, by Pythagoras theorem, okay, AC square is equal to hypotenuse, so sum of the squares of other two sides. That is 4 square plus 3 square, that is 16 plus 9, 24 implies AC is equal to 5. Or we know that the Pythagorean triplet, 3, 4 and 5, the longest side with the hypotenuse. Okay, or you will get using this Pythagoras theorem. Okay, so here it comes 5 centimeter. Okay, yes. Now we can solve the LHS separately and RHS, and if both are equal, you can say that 1 minus tan square A divided by 1 plus tan square is equal to cos square A minus sin square A. Otherwise not equal to. Okay, so we are taking the LHS part and we are solving LHS first. Okay, so 1 minus tan square A divided by 1 plus tan square A. This is the LHS. Okay, of this equation we are solving LHS part and we will get one answer. And in the second case we will solve RHS. That means solve LHS and RHS separately and see that both expressions are same. Okay, so this is equal to 1 minus. Okay, if cot A is equal to 4 by 3, its reciprocal is tan. Okay, so tan, what will be tan? Okay, so here you can write tan A will be the reciprocal 3 by 4. Okay, so here we need to substitute for tan square A. Okay, so tan square A is 3 by 4 whole square divided by 1 plus tan square. 3 by 4 whole square. Okay, so A by B whole square, A square by B square. So 3 square is 9, 1 minus 9 by 4 square 16. The 16 is only for 9. 1 is the first term. Okay, and divided by 1 plus 9 by 16. Okay, in the previous problem how we have done cross multiplication. So that means here you can write 1. So 1 into 16, 16, 1 into 9, 9 here divided by 1 into 16 and 1 plus 9 by 16 into 1, okay, divided by 16. Okay, as I told, in the denominator is a fraction, so take the numerator, take the reciprocal and multiply with the numerator fraction. So that means that 16 get cancelled. Okay, so you will have 16 minus 9 is 7. Okay, and 16 plus 9, 16 that get cancelled and divided by 25. That is 16 plus 9. I hope this step is clear. By taking the reciprocal, that get cancelled. Okay, so this is what about the LHS part. Now we can see what comes in the RHS. Okay, and what is RHS? Cos square A minus sin square. We are going to find out what is cos square A minus sin square A. Okay, that is cos square A minus sin square A is equal to cos square. That means we have seen that hypotenuse is 5. Okay, with respect to, we have seen that this was the figure I already rubbed. Okay, A, B, C. Okay, and this is 5. Okay, hypotenuse we have seen, and AB, that is the adjacent side. So 4 and 3 opposite side with respect to angle A. So sin A will be, what will be sin A? Here first term is cos. So cos A is adjacent side by hypotenuse. Okay, so adjacent side is 4 by 5 whole square minus sin square, opposite side by hypotenuse, that is 3 by 5 whole square. Sin theta whole square is sin square theta. Nothing is there in the denominator. Okay, so 4 square is 16 by 25 minus 3 square 9 by 25. Since both are like fractions, okay, subtract the numerators by keeping the denominator the same. That means 16 minus 9 is 7 by 25. Children, what we have seen? We have seen that after solving the LHS and after solving the RHS, we got the same answer. See, 7 by 25 is the answer for 1 minus tan square theta divided by 1 plus tan square theta. Here, what is it? This is cos square A minus sin square A. Also, we have seen that 7 by 25. That means both are equal. that is 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A. Okay. Now the next problem. Now we are solving the 9th question. Here in this question, we have given a right triangle ABC, right angled at B. Okay. If tan A is equal to 1 by root 3 and we have to evaluate this two part, that is sin A cos C plus cos A sin C and cos A cos C minus sin A sin C. What is given? Tan A. Tan A is free from hypotenuse and cos A and sin A we have to find out hypotenuse first. Okay, so we have to draw a right triangle and by applying the Pythagoras theorem we will get the hypotenuse. Okay children, so given tan A is equal to 1 by root 3. Okay, it is given that tan A is equal to 1 by root 3 and by relation, trigonometric relation for tan A is opposite side by adjacent side. So, opposite by adjacent. Okay. So, in order to get the third side, the hypotenuse, you have to apply the Pythagoras theorem. So, I am drawing a right triangle over here. Okay, right triangle and right angled at B. Okay, right angled at B, and then only you can calculate the acute angle. See, CA. So, C and A must be acute angles, and so angle B is right angle that is given in the question. Okay, so with respect to angle A, tan A is defined. Tan A opposite side is 1, okay, and its adjacent side is root 3. So, AC, that is the hypotenuse. So, AC square is equal to AB square root 3 square, okay, plus 1 square. Root 3 square is root and square get cancelled. So, 3 plus 1, that is 4. Okay, so this is AC square. So, AC will be square root of 4 is 2. So, this is 2. Hypotenuse is 2. Okay, so you can easily find out the remaining things. That is first sub question. That is, what is sin A cos C? Sin A cos C plus cos A sin C. First subdivision. Okay, and this is equal to, with respect to angle A, what is sin A? Angle A opposite by hypotenuse. Okay, that is sin A is equal to opposite 1 by 2. Okay, and what is cos C? Cos C is with reference angle change. Okay, with respect to angle C, see children, with respect to angle C, okay, cos C equal to cos C adjacent. Okay, adjacent, this is adjacent side of angle C, that is BC, adjacent side divided by hypotenuse, that is 2. So, we can substitute for sin A cos C. So, this is equal to sin A cos C equal to 1 by 2 into 1 by 2, 1 by 2 into 1 by 2 plus. Now, what is cos C? Cos C is equal to, with respect to this one, cos C, not cos C, cos A. Cos A, if we need cos A, we have to take the reference angle as A. Okay, so with respect to angle A, adjacent side is root 3 by hypotenuse. Understood children? So, cos A is equal to, we can write over here, okay, cos A is equal to, okay, root 3 divided by 2. Okay, and what is sin C? With angle change I, okay, so that is acute angle is C, that is sin C is opposite side, its opposite side is root 3. Okay, this is sin C. Sin C is equal to root 3 by 2. Hypotenuse remains the same for both acute angles. That is root 3 by 2 into root 3 by 2. Understood, children? So that should be clearly noted. The reference angle is very, very important, otherwise you will get the wrong answer. Okay. So cos A we have seen root 3 by 2 into sin C also root 3 by 2. Now we can solve easily. This is first term, this is the second term, and 1 by 2 into 1 by 2. Multiply the numerator 1 by 4 and denominator 2 2s are 4. And in the second term, root 3 into root 3, that is 3 divided by 4. Okay, 1 by 4 plus 3 by 4 is 1. And also, being their like fraction, denominator same, 1 plus 3, that is 4 by 3, 4 by 4, that is 1. That means, sin A cos C plus cos A sin C is equal to 1. That is the first part. And in the second part, okay, what is second part? This is second part, that is we have to find out what is cos A second part. Cos A cos C minus sin A sin C, and this is equal to what is cos A, children? Cos A I just rubbed. Okay, cos A we can find out. Okay, with respect to angle A, cos A equal to root 3 by 2. That is root 3 by 2 into cos C 1 by 2. This is angle C. So adjacent side is 1 by 2. 1 by 2 minus. Okay. And what is sin A? Sin A means 1 by 2. 1 by 2 into, okay, sin C. Sin C is root 3 by 2. Root 3 by 2. See, both are the same and they are subtraction, so 0 will be the answer. Let us see. Root 3 into 1, root 3, 2 2s are 4 minus 1 into root 3, 2 2s are 4. That means root 3 by 4 and root 3 by 4 get cancelled, so 0. That is cos A cos C minus sin A sin C equal to 0, and the first part we have seen that 1. Clear, children? This is very important question. This can be expected. Okay. Now we are moving to the 10th problem. Now we are moving to the 10th question. This is a very important problem. It is something different from the previous problems which we discussed. Okay, yes, children, what is given in this question? Here we have a right triangle PQR, right angled at Q. Okay, and PR plus QR, sum of two sides, that is equal to 25 centimeter, and PQ, that individual side, single side, is equal to 5 centimeter PQ. And we have to find out the values of sin P, cos P and tan P. Okay, so since it is given as triangle PQR is right angled at Q, we can draw first a right triangle PQR. Okay, so right triangle PQR, right triangle PQR. Okay, in this right triangle, okay, see here it is different from the previous question. There we have given directly one ratio. Okay, but here it is given as a sum of two sides. PR plus given PR plus QR is equal to 25, and PQ is a single side, that is 5 centimeter. So we can directly write PQ for, we can mark it as 5 centimeter. This is 90 degree. Angle Q is right angle. Okay. So how this can be done? This is very, very important question. Okay, since we need sin P, that means opposite side by hypotenuse. Okay, with respect to angle P, see, children, okay, we have to get opposite and hypotenuse. Okay, so that is why I told this is very, very important problem. So we are solving this in a very typical way. Okay, this problem can be done different ways, but I am showing you a very, very simple method. Okay, so here we are applying. Anyhow, we need the sides of the right triangle. So as usual we are applying Pythagoras theorem. Okay, that is square of the hypotenuse is equal to sum of the squares of other two sides. Okay, that is what we are going to write as the first step. Okay, that is by applying Pythagoras theorem, PR square is equal to PQ square, okay, plus QR square. Okay, PQ square plus QR square. Children, next what I am doing is, here we have given PQ. Okay, single side PQ. Okay, so I am writing this expression with respect to PQ. Why? Because you can substitute for PQ. We don't know what is PR or QR. Okay, if you can take a QR as X and that way you can do, but this is the simplest method. Let us see how this can be done using a new method. Okay, so I am writing this equation with respect to PQ, since PQ is given. Okay, implies PQ square is equal to, you can take this to LHS, okay, that is PR square minus QR square. Okay, what is given, children? Again PR plus QR equal to 25. See here, A square minus B square. What is identity? A plus B into A minus B. A square minus B square is A plus B into A minus B. Because of that identity, so this become, what this can be written as PR plus QR into PR minus QR. If you can write this equation of this form, in the next step you can substitute for what is PR plus QR, that is given as 25, and also PQ is given as 5. Concept is clear, children? Okay, so this is very important. First you express this in terms of PQ and apply the identity A plus B into A minus B. Then you can substitute. Okay, this is PQ square. Okay, so what is given? PQ as 5. So I am writing this as 5 square. Since PQ is given as 5. Okay, and PR plus QR is given as 25 into PR minus QR. PR minus QR. This step is clear, children? Okay, since they are connected by into, so this 25 square is 25. 25 is equal to 25 into PR minus QR. That means you can cancel 25 and 25. Okay, or PR minus QR equal to 25 by 25. Anyway, you will be getting 1. PR minus QR is equal to 1. Our aim is to get these two sides separately. Okay, so and now we have PR minus QR is equal to 1, and we have given PR plus QR is equal to 25. Okay, by elimination method solving. Okay, this can be cancelled. Okay, so 2 PR is equal to 26 by adding 1 plus 2. Okay, so PR plus PR, 2 PR coefficients can be added, and this can be cancelled since they are opposite signs, and 25 plus 1 is 26. Okay, from this you will be getting PR is equal to 26 divided by 2, that is 13 centimeter. Okay, that is PR. Now we know its actual measurement, that is 13 centimeter. And what is given, children? PR plus QR. PR plus QR is equal to 25. So QR will be 25 minus PR. What we have seen that PR is equal to 13. Okay, that is 12 centimeter. That is QR is equal to 12 centimeter. Concept is still clear, children? Okay, since PR plus QR is equal to 25 and PR we have seen that is 13. So QR will be 25 minus PR, that is 13, that is 12. Now we have all the three sides. Okay, now we can apply the result, that is ratio, relation, that is what is sin P with respect to the reference angle P. This we already marked. Sin P, single angle. So this is opposite side, this is adjacent, this is hypotenuse. Okay, so sin P, what is sin P? Opposite side by hypotenuse, opposite side by hypotenuse. Okay, so this will be 12 by 13. Then cos P is equal to adjacent side divided by hypotenuse, that is adjacent side is 5. Okay, PQ by PR. PR is 13. Okay, both having same denominator, that is hypotenuse. And tan P is nothing but opposite side by adjacent side and that is equal to opposite 12 divided by 5. This is very important problem. Okay, very easily you can solve this if you know all these steps very clearly. Okay, so do practice and get perfection so that you can easily get the answers of all the problems of this exercise. Okay, now we have one more question, that is true or false question. Okay, so in that question, state whether the following are true or false, justify your answer. The first question, the value of tan A is always less than 1. That can be explained only after I explain the theory part of the values of trigonometric ratios. Okay, so that can be done later. And second one, CK is equal to 12 by 5. Okay, for some value of angle A. Okay, see children, this is 12 by 5, it can be, and I already mentioned that CK is the reciprocal of cos A. Okay, cos A means adjacent side by hypotenuse. So, take the reciprocal means hypotenuse divided by adjacent. That means it will always a proper fraction. CK always a proper, okay, that means the numerator will be greater than, because longest side is the hypotenuse. So, that will comes in the numerator. So, this is true. Okay, CK can be 12 by 5. If it is 5 by 12, that will be wrong answer, false statement, because it will never be a proper fraction. CK always an improper fraction. Okay, so CK can take definitely an improper fraction. That doesn't matter. So, this is a true statement. Cos A is the abbreviation used for cosecant of angle A. This is very wrong. Cos A means cosine, the abbreviation of cosine. Okay, so this is false statement. Okay, cos A is the abbreviation used for the cosine of angle A, not cosecant. Okay, next is cot A is the product of cot and A. That also false statement. The ratio of an acute angle A, that is the mean. It is not the product of cot and angle A. That is false statement. Sin theta is equal to 4 by 3 for some angle theta. That also false. Why it is false? Here it is given sin theta as a improper fraction. How it can be an improper fraction? Sin theta is opposite side by hypotenuse. Okay, hypotenuse will come in the denominator, and that will be always greater than, that is the longest side. So, sin theta and cos theta always an improper is an proper fraction. But what is given in terms of improper fraction? So, this is again a false statement. Okay, so including this problem, children, we have completed the first exercise. Okay, thank you for watching and supporting my channel. Thank you all.